Hey, this is Nick Radowski from MyCodeTeacher.com. In this tutorial, you'll be learning how to use the accelerometer to move a ball around the screen. Now this will be like a smooth, it'll accelerate, it'll go faster depending on how far you tilt it. Similar to many games in the App Store where you roll a ball around, and we'll do some hit detection to make sure it doesn't leave the screen. So that's what you'll be learning. So let's get started right now. Open up Xcode. We'll go to File. First I'll close this. File. Not new file, sorry, I keep doing File, new project, and a view-based application. You can call it whatever you want. I'll call it Excel Ball, and I'll save it to my desktop. First thing we're going to do is add an image of a ball to our project. So we're going to open up the project folder, take this image of a ball, which I have here, and I'm going to paste it into the project folder. So we just have this image. It's got no background. It's just a ball, just like this. Very simple. This was made in I made it in Photoshop. You can make any ball. You can just make a circle, or just use any image, really, if you don't have an image of a ball. Grab one from Google, whatever you want, just to test the program. Open up your resources folder of the project, and drag the image from your project folder into the resources folder, then clicking Add with these settings set. They should be default. If they're not, change them. Okay, next we're going to open up our classes folder and open up our Excel Ball View Controller. I'm just going to expand the editor, expand my window a bit, make it a little easier to see. First thing real quick, we're just going to want to create one IB outlet. Now, this is not a tutorial on interface builder, so if you don't know IB outlets and actions, go look them up. There's tutorials that teach you how, and it's very simple. So IB outlet, we'll create a UI image view and call it ball. That's all we need to do in terms of interface builder. Now we'll open up the Excel Ball View Controller nib file, because we just did that in the viewcontroller.h file, like I said. And in your view here, just in your library, if you don't see it, go to Tools, Library, and in your Media tab, you'll see the ball. Just drag it out into the view. Now, I'm going to make the ball 50 by 50 as the size in the sizing panel right here. And you see the ball did not shrink because in the Attributes tab, the first tab in your inspector, Tools, Inspector if you don't see it, you'll see the mode is set to center, so the image will always be centered and not scaled no matter what you change the size to. We'll change that to scale to fill, and the ball will become the size that you adjust it to. Remember, I made mine 50 by 50. You're welcome to make it other things, but then you're going to have to change some things during the tutorial, so I recommend 50 by 50 for your size. Now just click Files, Owner, which if you check the identity, sorry, can't seem to click it. There we go. It is the view controller, and if you go to the Connections tab, you have ball. We can connect it to our ball. Now the interface is laid out, we could save Interface Builder and quit it. Just go back to our project. So now let's go into the .m, and first we are going to define a value based on the size of our ball. So above the implementation line, but below the importing, do a number sign, define, and we'll call all caps ball underscore radius. And we'll say 25. What this line says is that anytime we use this ball radius in our program, the program will read it as 25. That is the value of ball radius. This will make it so that if we ever change the ball's radius, like if you made it a different radius, let's say you made the ball 60 by 60, the radius would be 30, because the radius is 1/2 of the width, 1/2 the diameter of the ball. You can just change it to 30, and all the times that ball radius is used throughout the program will be changed to 30, so it just makes it really easy to change things quickly. So since we're using the accelerometer in this tutorial, we're going to have to access the accelerometer values in this file. To do that, we'll open up our awake from nib function, just like this, -void awake from nib. This function is called when the program launches and when this view is called up, the one that has the ball in it. Now we're going to set up the accelerometer. You do it like this: UI accelerometer, shared accelerometer, set update interval, and we'll set it to, how about 1.0 over 30.0. So the accelerometer values will update 30 times every second, so it'll be very fast. In the next line, do UI accelerometer, shared accelerometer, set delegate, self. So this file will be the delegate of the accelerometer. What that means is whenever the accelerometer values update, it'll call the function which we're going to implement next, the accelerometer delegate method. So first what we need to do is we need to go back into our .h and right here declare this as the UI accelerometer delegate. You can go read the iPhone Beginner's Handbook that comes with your subscription to MyCodeTeacher, or view other tutorials to learn more about delegates. But this is pretty much just saying that when the accelerometer updates value, call the method in all the accelerometer delegates. In this case, this file. We'll call this method. Let's go grab it right now. I don't know it right off the top of my head. So let's just go into our documentation, which is taking a long time to pop up. There we go. And type in UI accelerometer. You have it right here. And if you just take a quick notice here, you see there's that shared accelerometer method I was using to grab the accelerometer of the device. If we go to the UI accelerometer delegate, there's one method, accelerometer did accelerate. We'll copy that and paste it into our program in the viewcontroller.m file. So like I was saying, every time the accelerometer values update, this method will be called and you could grab the accelerometer values. Now we could close the documentation and we'll just be working in this method from now on. Now in this method, what we're going to be doing is actually moving the ball. So you'll see this method gives you an acceleration. If we go look in the documentation real quick, you'll see that the UI acceleration right here has four things: X, Y, Z, and timestamp. If you look at this chart up here, this is the X and Y coordinate plane is across the device this way and up and down the device this way. So if we're holding the device parallel to the floor in landscape position, tilting it forward and back will be X here and here, and tilting it side to side will be here and here. So we're not going to be dealing with Z because we're moving the ball around the screen by tilting the device. So we're just going to be looking at the X and Y values by calling X and Y. So first what we're going to have to do is create some values to hold the acceleration values. So create a float value X. We're using floats because these will be decimals, not integers, so not whole numbers. And then also in the H file we need a float value Y. We'll use these to store the acceleration values. So first we'll go value X equals acceleration.x and value Y equals acceleration.y, lowercase, not uppercase. Now that you have the values, we're going to have to generate new X and Y coordinates for the ball on the screen based on these acceleration values. So what we'll do, we'll create an integer, new X equals ball.center.x, so that's the current X position of the ball, plus value X. And that'll create a new X coordinate for the ball. However, you'll notice value X is a float and ball.center.x is a float, and we're trying to get an integer so we can add a nice even number to the X coordinate. So do this in front of it. Put int in parentheses. This will say whatever value you get, convert it into an integer, and then we could store it as an integer over here. Now the next problem we have is value X. These are values between 0 and 1, so they're very, very small. So in order to actually see some motion, we're going to multiply it by like a speed scaling. So for now we'll pick 30. We'll multiply it by 30, each the X and Y. So now the ball will move a little faster. It'll be more easy to see. Now we have some bigger values. So instead of like 0.5, we'll have 15. And it's much easier to work with. And then we have to do the same thing, copy and paste this line with the Y. We'll change it to new Y, an integer, the ball.center.y, and then we're going to actually minus the value X, because if you remember from that chart, positive Y was up, but in the screen dimensions, positive Y is down, so we're going to minus value Y, we're going to minus value Y instead of adding value Y, or else the ball will go in the opposite way the device is tilted. So now that you have new X and Y's, you can create a new CG point, new center, and call them as CG point make. This is the most common method for creating CG points. and we'll just say new x is the new x of this point, and new y is the y value of this point. And then the final thing to do is set the ball dot center, the ball center, to the new center. Now let's build the project real quick. So you can go to build, or just Apple B, and make sure we don't have any errors here. Succeeded, so we do not. And I'm just going to switch cameras here, just run the program on my device, because the simulator doesn't generate accelerometer values. You'll need a device to test this. I'm going to run it on my device and show you how it works. Alright, so I've now launched the program, and as you can see, we just have a ball on screen that as we tilt, moves around based on the position, the acceleration of the device. You'll see if I do a small turn, it's very slow motion, and a big turn is a very fast motion. So it's based on the tilt of the device. However, you notice if I tilt too far, it goes out of the screen. So now we need to do some hit detection to keep the ball on the screen. Let's do that now. Okay, so in order to keep the ball on the screen, every time the ball moves, we're going to have to check that its X and Y are inside of the screen, and if it's not, put it back, keep it in the screen. So let's separate X and Y here, and first work on the X. What we're going to do here, we're going to do some if-then statements. We're going to say, if the new X is greater than 320, which is the width of the iPhone screen, because the X is the the shorter width of the iPhone screen, because we're tilted in a landscape, minus ball radius. So if the new X is at the edge of the screen minus the half the width of the ball, which we put at 25, what we're gonna do is we're gonna say new X equals 320 minus ball radius. So now when the ball went out of screen, now it'll stay in the screen. It won't keep going. If it's at any point, if it's greater than 320, it'll stop. We're going to do the same in the other direction. If new X is less than 0 plus ball radius, then new X equals 0 plus ball radius. And that'll keep the ball in the screen in terms of the X direction. Now the Y direction, we're going to do the same thing, copy and paste here, except change all the new X's to new Y, new Y, new Y, new Y. In the first line, instead of 320, we're going to do greater than 480 minus ball radius, because that's the width of the other end of the screen, and change this to 480. And then keep this one at 0 and 0. And this will keep the ball in the Y direction. So we're going to go ahead and we're going to run this on the device. So let me just switch cameras here. Actually, I'm sorry, before we run on the device real quick, I just realized one quick thing. Let me just show you something. If you go to real quick, open up the nib file and take a look. You'll notice that that this toolbar up here is actually part of our Y view, and we don't want the ball to go behind the toolbar. And it won't as of now, because this is still the 0 mark. However, you have to take note that because the toolbar's there and the toolbar's 20 pixels, the bottom of the view is actually 460, not 480. Like if I go in here, you see it says 460 right there. So we actually have to count for that in our code and change this from 480 to 460 to actually get the ball to stop at the bottom of the screen and not go 20 pixels into it and then stop. So now I'm going to go run on my device after I build and make sure it's successful. Succeeded. Okay, now I'll build on the device. Okay, so now when I launch the program on the device, we still have our ball that moves around based on the acceleration. If I tilt all the way this way, see, it stops. It detects the walls, and it stops. See, that we set it to 460, so it stops right at the bottom. In all directions, the ball will stop. So now you're keeping the ball within the screen. And really, that's it. We just did it. That was the tutorial to learn how to move the ball around the screen using the acceleration. It's a nice smooth animation with the update set to 30 times per second, and multiplying the speed by the acceleration values by 30 created a nice looking thing. You could play around with that value, change 30 to 60, and the ball moved twice as fast. Change the ball radius if you change the size. There's a lot of different things you can mess around with. And yeah, that's pretty much it. So good luck if you implement this in your project. As you saw, very simple. Just keep in mind you need a device to test it. So don't go and write a program if you write this program if you can't test in the device, because in the simulator, no acceleration values. The ball will just, I believe it just stays there. So yeah, hope you enjoyed.